In this example, we're asked to find the domain and sketch a graph of the given function. And here we have the function f of x is equal to the square root of x plus 4 minus 1. So the first thing that we need to do is find the domain. Now, we need to be particularly careful with this case because we're working with a square root. So we want to recall what are the domain restrictions for a square root function. So since we know that the inside cannot be negative, to find the domain of the square root function, we want to set the inside, or that radicand, greater than or equal to 0, and then solve for x. So we have the inside, x plus 4, must be greater than or equal to 0, and we want to isolate x. So we can subtract 4 from both sides here, leaving us with x is greater than or equal to negative 4. Or in other words, in interval notation, we can say that x is an element of the interval from negative 4 to positive infinity. So now that we have the domain of this function, we're ready to set up our table of values to find the solution points x, y to plot on our coordinate plane. So keeping this domain restriction in mind, we'll choose appropriate x values. So again, I've selected 5 different x values here, our inputs, and we're going to input these values into our function to find their corresponding y. So we've plugged these input values into our function to find the corresponding y values. And we can see here that when x is negative 4, y is negative 1. When x is negative 3, we have determined that y is going to be 0. Now, for these next two x values, negative 2 and negative 1, we can't simplify any further than this. So we're going to leave our final answers for y in their irrational form. So you have negative 2, the square root of 2 minus 1 is our y value, and the same idea here for negative 1. So you have the ordered pair negative 1, and y is the square root of 3 minus 1. And last but not least, when x is 0, we found y is 1. So when we go ahead and we plot these solution points on the coordinate plane, let's only use the whole numbers for convenience. So we have the ordered pair negative 4, negative 1. We have the ordered pair minus 3, 0. And then skipping down to our last ordered pair, 0, 1, our y-intercept. And again, to see the graph of this function, we just need to connect these ordered pairs with a smooth curve. Now again, notice here from the graph, we can see the range. We're observing our very first point on the graph here, negative 4, negative 1. Minus 1 is the smallest y value. So thinking about this on our corresponding y-axis, we start here at negative 1, and y can be any real number greater than that value. So therefore, our range, we can say that y in interval notation is going to be greater than or equal to negative 1. Or writing this in its corresponding interval form, we have that y is an element of the interval from negative 1 to positive infinity.